Welcome! In this video we will derive a finite difference approximation for a term in a differential equation which is equal to the first derivative of px times y prime x, where p times y prime also appears in the left or right boundary condition. Here we see a general boundary value problem with this situation. P times y prime appears in the left and right boundary conditions, shown in red. And its derivative is part of the differential equation, shown in blue. We will derive a finite difference approximation of the derivative of px times y prime x in the remainder of this video. Let's start with the well-known definition of the first derivative of a function y. From this definition we can derive several formulae for approximations of the first derivative. One of these approximations is shown here. It's called the forward difference. It uses function values in the grid point x and the next grid point x plus delta x. As can be seen on the slide, for large time steps the approximation of the first derivative of function y is not very accurate. The dashed green line is far from parallel with the solid green line. The forward difference formula is a first-order approximation of the derivative of function y. An alternative approximation called the central difference uses the grid point to the left and to the right of x. Even for large time steps, the approximation might already be much more accurate, as can be seen here. Even with the large time step taken here, the dashed green line is almost parallel with the solid green line. The central difference formula is a second-order approximation of the derivative of function y, and approximations of higher order usually allow larger time steps to meet the desired accuracy. Our goal in the remainder of this video is to find a finite difference approximation for the first derivative of px times y prime x. We will also use central differences, so the finite difference approximation will be order delta x squared. Furthermore, we only want to use function values of y at locations x minus delta x, and x plus delta x. Let px times y prime x be called gx. Then we can approximate g prime with a central difference. Because gx is px times y prime x, the blue part in the formula can now be substituted with the blue part in the formula at the bottom. And in the same way the green part can be substituted with the green part. This slide again shows the formula we have found so far. Still, there are first derivatives involved, shown in blue and green. We will again approximate these first derivatives with central differences. In the central difference for location x plus delta x, we use locations x and x plus 2 times delta x. In the same way, for location x minus delta x, we use locations x minus 2 times delta x and x. This leads to this equation, with again the blue part substituted by the blue central difference and the green part by the green central difference. And after bringing this under one denominator, we find 4 times delta x squared in the denominator. Did we find the desired formula already? The answer is no. One of the conditions was to only use function y at locations x minus delta x, and x plus delta x. And that's not true anymore. Now we use y at location x, but also at x plus 2 times delta x, and at x minus 2 times delta x. How can we solve this problem? The answer to this question is take steps of a half times delta x. Delta x becomes a half times delta x, which is shown in red, and 2 times delta x becomes delta x, which is shown in green. Finally, 4 times delta x squared becomes delta x squared, which is shown in blue. The only thing still to be done now is writing the formula in a better readable way. We simplify the notations for xj plus a half delta x and xj minus a half delta x in this way. Furthermore, we use wj minus 1, wj and wj plus 1 for the approximations of y x minus delta x, yx and yx plus delta x. Substituting this in our formula leads to the final formula for the approximation of the first derivative of px times y prime x at location xj. P is a known function, so function values can be evaluated at arbitrary positions, including positions halfway between the grid points, and wj minus 1, wj and wj plus 1 are the approximations of the function values of function y at the grid points. We have reached our goal for this video. The formula we have derived here will later be used in class. Goodbye.